selection device. So we've talked about, different types of selection batteries, putting a bunch of tests together, different ways to combine the tests in the battery, perhaps simply adding their scores together, perhaps weighting them in some way using a regression procedure, etc. Okay, but now the question is, how useful is it? And so the number one idea in useful is to say utility. Utility in psychology is sort of like value. What's it worth to you? What does it give you? Right? And in order to assess the utility of a selection battery, you have to know a variety of things. Number one, how accurate is it? And which is obviously highly, highly, highly related to validity, right? But you also need to know the base rate. That is, you must have already had something in place, and how good was your existing thing? Because you don't just look at how good is the selection battery, you have to look at how much better is it than what we already were doing, okay? We have to look at the selection ratio, which is a function of how many positions there are to fill and how many applicants there are. And then, of course, the costs, right? These things really cost money. Okay? So as we can see in this very pretty graph, we've got a situation where on the x-axis, we've got the score on the predictor battery, okay, the set of tests, selection tests. On the y-axis, we have the criterion, and the criterion is always, well, not always, be careful, but in IO psychology, the criterion is almost always job performance or some version of job performance, because later on, we're going to find all kinds of ways that job performance is quantified, including, number of units produced, but also in terms of counterproductive work behaviors. So job performance is also measured by tardiness and absenteeism and stealing from the company and things of this nature. So in this graph, you can see what happens along the x-axis is that we've got this solid vertical line, and any score to the right of this vertical line, we will hire. That is our minimum cutoff. Anything to the left, we will not hire. Okay? Then what's going to happen is that along the y-axis, you see this solid horizontal line, and that is going to be, is this a successful employee? Will their job performance be high? And so we have set this arbitrary cutoff line. Anybody that performs above this line is considered successful, and anybody below this line is considered failing. And so in this layout, we've got these four quadrants here. We've got hits, misses, false alarms, and correct rejections. And so everything above the line is people that would be successful at the job. But people above the line and to the right are people that we hired, and they are successful at the job. See, these, we like hits. Hits are awesome in the selection procedure. Misses, on the other hand, are people that would have been successful, but because of what their score was on the predictor battery, we do not hire them. We missed potentially decent candidates. Below the line, these are all people that do not perform well in the company. They're not successful, they're failures, okay? And everything over here in the bottom left corner, the selection battery predicted that they would be terrible employees. They were, in fact, terrible employees. We did not hire them. That's great. On the other side, on the right side, however, you've got false alarms, and this is potentially a problem. Your selection battery said, yeah, I think these people are going to be successful, but then they are not, and now it's 1 year later, and you've got a lot of baggage here. Look at all this baggage. You hired them, you trained them, you invested in them, and they're not performing. Okay? And so perhaps you've seen, are more familiar with seeing a layout such as this, in particular from your statistics class, okay? Or your experimental class. And so what you see here is the terms we use in the stats class. Remember, the type 1 error, also called false alarms, is alpha. The probability of this occurring is alpha. And so the probability of making a correct decision is 1 minus alpha. And maybe you remember the type 2 error is beta, and the probability of making a correct rejection, which is also known as power, is 1 minus beta. And if you recall some of your background in your statistics class, what you find is that whenever you make a decision, whether you're doing statistical hypothesis testing and deciding whether or not to reject the null hypothesis, or a selection decision in hiring a new employee, you're going to make errors, and errors always come with costs. And so the IO psychology, when evaluating the value of this predictor battery, would have to say, okay, false alarms have this cost. Wasted salary on these people, I wasted training, they're invested in my corporate culture, and now I have to move them out. Maybe even though this guy is a failure, maybe he's real popular and he's collegial, and maybe everybody loves George, and and now you got to be the bad guy to fire George because he's a shitty employee. Or misses, right? These were employees that could have helped productivity in your corporation, could have really made the world better, but you didn't get them. Okay? So here's an instance where the selection battery, as you can see, the correlation here, the validity, is essentially zero. It's so close to zero as to be zero. And so if your predictor battery has a validation correlation approximating zero, don't bother. Okay, don't bother using the predictor battery. You should just close your eyes and flip a coin and say, you're hired, you're not hired. I mean, that's what you're looking at. Or more specifically, as the IO psychologist, pack your bags, son. Go find a new job. Okay, so when considering how useful a selection battery would be, we also, as I said previously, need to consider the base rate. So it's not just how good am I at selecting employees, but how much better am I than the old method? And so to establish how successful the older method is before you develop a selection battery, you go into the company and you look at all the employees and you find some way to quantify what equals successful. And so what you're going to do is create a base rate of successful employees divided by total number of employees, because successful plus failing is just another way of saying all employees, okay? And so you're simply going to create a ratio here, or more specifically a percent, and then you're going to use that and determining what does your new selection battery do. Okay? Another incredibly important consideration is the selection ratio. So if you have 20 positions that need to be filled, and you have 20 applicants, the selection ratio is 1.0. It's 20 over 20. And therefore, what is the point of your selection battery? You had 20 positions to fill, you had 20 applicants, you are all hired. Okay? So you might as well not even bother with a selection battery. There's no point to it. But say there's 5 openings for 20 positions, or no, rephrase that, 5 openings and 20 applicants, the selection ratio is 5 over 20 or 0.25. And now all of a sudden, that you can use a selection battery to find the most qualified candidates. So as the selection ratio gets smaller, the selection battery gets more and more, has potentially more and more usefulness. But also costs. And this is a real consideration that we addressed earlier when we talked about the multiple hurdles approach. And that was to say, if you remember when we were making a selection for a cardiac surgeon, the first we lined up the tests inside of our selection battery from least expensive to most expensive. And we started on the least expensive side, medical school GPA. It was very inexpensive and cheap to measure. And based on that, we said, Dr. Oz, you're out of the game, okay? And so we start to minimize the costs of a selection battery by simply having cutoffs and removing from the pool, so that as you're getting more and more expensive testing, you're testing fewer and fewer and fewer applicants. Okay? But perhaps in even more so to the cost side, though this is related to the costs, the question is, as you can see if you study the full notes rather than just this summarization presentation. If you look at the full notes, you'll see the Taylor-Russell tables. And the Taylor-Russell tables are a little confusing, but if you wink your eye at it, you can work them out. Okay, they're not that confusing. And so the Taylor-Russell tables allows to quantify how good a selection battery is. Okay, and so you combine that with your base rate, and you come up with, let's say, for example, My new selection battery allows for an 8% improvement in the percentage of successful employees. Okay, great, great. What is 8% worth? How much increased productivity do you get in your corporation from 8%? How much money did it cost to implement this new battery? Maybe if you've already developed the battery and you're evaluating it, maybe you have sunk costs in the fact that it's already a developed battery, so moving forward you don't have to have all of the costs of development. So maybe 8% is, a okay thing. Or, you know what, selection batteries can actually be used valuable in an incredibly other way, and that is that, as we're going to get to in the next couple of videos, that those places where companies are going to get sued for discrimination is going to be in the selection process. I mean, there's other places, but the selection process is the biggest place. And if you have a selection battery that will protect you from lawsuits, or will allow you that, in the rare case that you get caught in a court of law, that a jury will side with you because you have established a valid selection battery that does in fact predict successful employees, so you can cover your BUTT in a court of law, that has a huge value. Okay? So when we come back in the next videos, we're going to start to actually talk about the intersection between the human resources side, the I side of IO psychology, and the legal system.